Assalamualaikum warahmatullahi wabarakatuh and very good day. Today I'm going to give you a lecture on testing group differences. I will show you my slide. Alright. For the lesson outcome, after completing this lecture, you should be able to know the parametric and non-parametric tests, know the t-test, one-way ANOVA, Mann-Whitney, Wilkinson rank test, and Kruskal-Wallis are when they are appropriately to be used. Third is how the null hypothesis can be rejected or not for each statistical test. Okay, here is the parametric versus non-parametric test. You can see the differences here. For parametric tests, okay, there are paired t-test, independent t-test, one-way ANOVA, Pearson correlation, and also regression. For non-parametric tests would be Wilkinson sign rank test, Mann-Whitney, Kruskal-Wallis, chi-square, and also Spearman correlation. If you notice, okay, the parametric test and non-parametric test, okay, it is the pair for the paired t-test, okay, if something similar with the paired t-test, but it is not parametric test, you can choose the Wilkinson rank test. Okay, if you want to run something similar with the independent t-test, but it is non-parametric test, you should use the Mann-Whitney. Alright. Okay, this is the pair for the, this slide show the pair for the test that you can use for parametric test, and this is for non-parametric test, which can give you a result. Okay, for parametric test, okay, it is used for normally distributed data, and it has more statistically power than non-parametric tests. Parametric tests can be indicated by the histogram and also the Kolmogorov, Smirnov test, or Shapiro test, wing test. Assalamualaikum warahmatullahi wabarakatuh and and good day. I'm Madam Rose. Today I'm going to give you a lecture on testing group differences. Well, now I will show you my slide. Okay, give me a moment. Alright, okay. Testing group differences. Okay, for the lesson outcome, after completing this lecture, students should be able to know when parametric and non-parametric tests, know when the t-test, one-way ANOVA, Mann-Whitney, Wilkinson rank test, and Kruskal-Wallis are appropriately to be used, and know how null hypothesis can be rejected or not for each statistical test. Okay, here is the table that can show you the differences of the parametric test and a non-parametric test. If you notice, here is the pair of the parametric test and non-parametric test. Let's say you have a data is a parametric test, what we consists of parametric test. Here is the parametric test consists of paired t-test, independent t-test, one-way ANOVA, Pearson correlation, and also regression. For non-parametric test consists of Wilkinson sign rank test, Mann-Whitney, Kruskal-Wallis, chi-square, and Spearman. Okay, this arrangement is the pair of each other. Okay, let's say you have a data okay, similar to the PET test, but it is not suitable. Let's say you have certain circumstances that you cannot use the parametric test. Okay, you have the alternative uh, test, alternative test that you can use, Wilcoxon sign rank test. All right. What is a parametric test? Parametric test can be used for normal distributed data, has more statistically power than non-parametric tests, and it can be indicated by the histogram, Kolmogorov Smirnov test, or Shapiro-Wilk test. Okay, if you see here, for the parametric test, the data should be normal distributed. Okay, for the non-parametric test, okay, it can be used for not normally distributed data. When you have ordinal data, rank data, or outliers that you cannot remove, you have to use the non-parametric test. It can be indicated by the histogram and also Kolmogorov Smirnov test or Shapiro-Wilk test. Okay, here is the illustration for the not normally distributed data. Okay, this is the data distribute quite normal, but unfortunately there is outliers here. So if you cannot remove these outliers, so you have to use the non-parametric test. If you can remove the outliers, that means you can use the parametric test. Okay, what is t-test? T-test assess whether the means of two groups are statistically different from each other. And this analysis is appropriate whenever you want to compare the means of two groups. Okay, like here, 2, T for 2, this means for two groups. Okay, t-test, you can see here. Okay, this is a mean of the control group. You want to compare with the mean with the treatment group. Okay, this is few example. This is a medium variability. Okay, this is diagram show high variability, and this diagram show is a low variability. Okay, you don't have worry much about this formula. It just show you the difference, how you get the t value for the t-test. Okay, there are 5 factors contributed to whether the differences between two groups mean can be considered significant. First, how large is the difference between the means of the two groups? How much overlap is there between the groups? Is this a function of the variation within the group? How many subjects are in the two samples? What alpha label is being used to test the mean difference? And is a directional one-tail or non-directional two-tail hypothesis being tested? Alright, there are two types of t-test. Okay, first is the independent t-test. Second is the paired t-test. Okay, independent t-test, okay, this is concerned with the differences between the average of two populations. It compares the average of two samples that are selected independently of each other. Okay, here is the illustration. Let's say the mean group score for, mean of stress score in group A. Okay, this is a mean or stress score in the group B. Okay, different people. Alright, I believe you can check the example in the lecture notes. Okay, for the t-test hypothesis, okay, H null mean that the two population means are equal. Okay, while the alternative hypothesis is the two population means are not equal. Okay, can we reject null hypothesis? Okay, the calculated t-value is then compared to the critical t-value from the t-distribution table with the degree of freedom n1 plus n2 minus 2 and chosen the confidence level. If your calculated t-value is greater than the critical value, then we reject the null hypothesis. Okay. This is the critical value. This is the calculated t-value. Okay. And what happened? How you going to make the decision? If the calculated t-value, okay, is more than critical t-value from the table, you have to reject the null hypothesis. If the calculated t-value is lower than critical t-value, do not reject the null hypothesis. It's something like that. Okay, if your calculated value is more than the critical value, you have to reject the null hypothesis. All right. Okay. What about in the software? Sorry. Okay. This is a decision that you make if you have to calculate it manually. All right. Okay. In the software, especially in the SPSS software, how you're going to make decision? Okay. Let's say this is the obtain p-value, okay, that calculated p-value, and then this is just chosen p-value. How to decide? Okay, let's say if the calculated p-value is lower than chosen p-value, you have to reject the null hypothesis. But if calculated p-value, okay, higher than chosen p-value, okay, do not reject the null hypothesis. Alright, here in the SPSS output, here, okay, this is the t-value, this is your p-value. Okay, next we move to the PET t-test. It's compare the average of two samples that are dependent or paired of each other. Okay, it's also compare the difference between the mean score of the same sample of individual who are assessed at two different times, such as before treatment and after treatment. Okay, can you see here? The illustration here. If you see, they are same person here. Okay, they are same person. Okay. This is a mean cholesterol level before taking the statin, okay, on February, and a few months later, the mean cholesterol after taking the statin. The same person but different treatment, before and after treatment. And PET t-test also can be used, okay, to compare average score of sample of individual who are paired in some ways, such as siblings, mothers, daughters, person who are matched in terms of particular characteristic. Okay. Okay, example. I think you can read this example in your lecture notes. Okay, now we look at the null hypothesis for the PET t-test. Okay, null hypothesis is the PET population means are equal And while the alternative hypothesis, the pet population means are not equal. Okay, can we reject the null hypothesis? Okay, if the calculated t-value is then compared to the critical t-value with degree of freedom equal to n minus 1 from the t-distribution table for a chosen confidence level. Okay, if the calculated t-value is greater than the critical t-value, then we reject the null hypothesis and conclude that the means are significantly different. Okay, this is decision that you can make if you calculate manually. Okay, the critical t-value and calculated t-value. If you have calculated t-value is more than critical t-value, okay, you have to reject null hypothesis. When you reject the null hypothesis, that means that there is the when you reject the null hypothesis, it means that they have the means are not equal. Okay. Here, calculated t-value, okay, is lower than the critical t-values. Mean do not reject the null hypothesis. It means that they have the same uh, uh, same value of the means. Okay, here, let's say your calculated value is more here, okay, you get higher than critical value, you have to reject the null hypothesis. So do here. Okay, in the software, okay, if you have your calculated p-value, okay, lower than the chosen p-value, okay, you have to reject the null hypothesis. When you reject the null hypothesis, that means that the means are not equal. If the calculated p-value is more than chosen p-value, okay, this means that you do not reject the null hypothesis, meaning that they have the same value of the means. Okay, this is a SPSS output. Here for tab t-test, you can see here t-value and also the p-value. Okay, take a break. See you later.